3, 2. Welcome to today's ViodiTV real-time conversation. Oh my gosh, I'm excited because we've got Tom Coughlin and the Merkley brothers from Locomation. So we're going to talk about, as technologists are reaching for the stars with amazing new technology, it's really important that the fruits of those exciting breakthrough developments are available for everyone. And at the same time, for those developments to reach their full potential, how are the decisions going to be made? It can't be made necessarily by a select group, a few, to make the decisions for the rest of us. So the questions that we'll be asking today is, how can professional associations, academics, and industry work together to ensure that the most good can be done for the greatest benefit possible? And I think that also includes, to paraphrase my friend Alan Kornhauser, is bringing and getting communities involved as well. All those things play into this. And who we have here, first we have Locomation. And Locomation, you may have seen the ViodiTV interview from CES a couple years ago. They're doing some very interesting things in automating the trucking industry to really improve things for the driver as much as improve efficiency, and which could lead to better results for the end customers, for the people who buy and want things like fresh fruits and vegetables, for instance. And then we have Tom Coughlin, who's past IEEE-USA president. He's the current president-elect for IEEE 2022.
Candidate.
Oh, go ahead. I'll let you jump in, Tom, and clarify that. Candidate.
Yeah.
And he's also a storage expert and consultant. And I've been helping Tom, full disclosure, I've been helping Tom with his campaign edit videos. I'm not an IEEE member, but having seen the way Tom works, and as importantly, seeing the types of volunteers and the number of volunteers that get involved with, the types of things that Tom wants to do to extend beyond the reaches of IEEE, I have to give my support to Tom. So, I thought that there'd be an interesting conversation today to get these folks together, and we'll start with you, Tom, and why you think it's important to get the IEEE and the industry together, and then we'll ask Satan and Taken their thoughts on Locomation and how they came out of Carnegie Mellon to start that enterprise. So, Tom, why don't you kind of give us your thoughts on the IEEE and why it's important to work with industry?
Sure. So the organizations which became the IEEE in 1963, such as the American Institute of Electrical Engineers, were founded by folks from industry, giants at the time, Thomas Edison, Alexander Graham Bell, Tesla, so IEEE has its roots in practical applications of technology. And IEEE has been having, in my mind, a crisis that we have been losing members in industry in the IEEE since the turn of the century. And it's a significant loss of members. I think something like 50% of the industry members have been lost over that period of time. And I think we need to do, IEEE needs to change a number of things that we do to create greater value for members who are in industry, and more participation and connection with activities that would be attractive to industry or that would benefit industry. So it's a real important thing that IEEE does, is to strengthen those connections, again, both for the members in industry and also for the ideas in industry. And one of the big things there is something that I think is a real value potentially if we use it better, is IEEE's Future Directions Committee, which is looking at technologies that can change the world, and for IEEE to engage with those early. So, and I know that the folks speaking here today have actually done some things with our IEEE Future Directions Committee. So I think making those kind of connections, I think, is important.
Tom, that's a great introduction. And Locomation, I think, is unique because you guys as co-founders came from Carnegie Mellon, you came from academia, and then you founded Locomation. So I think we'll explore that connection. But first, tell us about Locomation, and I'll bring up your website while you do that.
Perfect. So given that Tekin is heavily pixelated, maybe I'll start by giving the overview, and he can jump in as he sees fit. Locomation is a full stack self-driving company. Our overall goal, long-term goal, is actually to automate everything that moves. So that's actually hidden in our name. It's the mashup of locomotion and automation. But that's obviously a very vague and very long-term goal. And we need to start with something very tangible, very near-term, and stay focused. So when we take in myself and our rest of our co-founders, when we were still full-time faculty members at Carnegie Mellon's Robotics Institute, and we decided to start Locomation, we did a really meticulous analysis of what we should focus on to build a successful business that relies on innovation, but ultimately it's the business case that's going to resonate and make it a long-lasting endeavor. And freight automation, and particularly middle mile freight automation with trucking, was really obvious from our point of view as the ripest part of the supply chain to disrupt. It's not just the largest portion of the freight industry, it is also the portion that suffers from significant pain points such as increasing driver shortage and chronic asset utilization problems. So it's a very low margin, very archaic industry that hasn't changed in the way it functions in almost a century. And obviously now that the world is heading towards a different direction, the socio-economical behaviors are changing in sometimes irreversible ways. We are relying more and more on e-commerce. The manufacturing back end of the industry relies more and more on modern philosophies like just-in-time manufacturing and zero inventory manufacturing. So everybody wants to ship more stuff around, wants more visibility, accuracy, and certainty around the shipment workflows, and wants to pay less for it. So we decided to focus on freight automation, and particularly middle mile automation, as our first step. So that meant semi-trucks. But then the thought of eliminating the human driver and making an 80,000-pound truck drive itself with no one around at 70 miles an hour, the required safety and reliability evidence for the mass deployment of that technology is going to take a long time to accumulate, and it's actually going to take a clever way of exposing the technology to the real world at scale in a safe manner. So our little workaround for this was to adopt a portfolio approach and adopt a phased approach to autonomy, starting with human-guided convoying. We said, okay, so let's build an autonomous truck, fully autonomous truck from day zero, but initially let that truck drive itself only as long as it is driving right behind a human-driven leader truck, like a little duckling, and go wherever the lead truck goes. That enables us to solve important, significant, and fundamental problems of autonomy and create a safe foundational layer from get-go, and leaves what they call the long-tail problem, all the little variations in the real world, all the edge cases, all the situations that we can't even imagine by definition, solving those to the later stages as we start deploying the convoys, start generating value. Of course, as a company, we like the idea of making money in the process, and collecting vast amounts of validation data from real world. So that's how Locomation came to be. We've been around for a little bit over 3 years. We are fashionably late to the autonomous driving party, but upon our arrival, we made immediate significant progress, and we got to a point where we have strong commercial traction as we speak today.
Yeah, you've got quite a few contracts with established trucking companies, correct?
That's very true. In fact, as we speak, we are the only company in the autonomous trucking space with firm purchase orders.
Wow. Are there any on the road yet?
Our test trucks are on the road, but our commercial deployment is still several quarters away. we are aiming to launch in the second half of next year.
Does that
And these are, oh, I'm sorry. I was just going to say, those are physically, those are your trucks right there, right?
Oh yeah, yeah, familiar pictures. I've seen them. So these are what we are seeing on the screen, and I hope that our audience can see them too. This is our first generation trucks. We recently rolled out our third generation trucks that we probably don't have their pictures up there yet. And as we speak, we are, of course, already working on the generation after that. We believe we will go through a couple of more iterations before we finalize or at least freeze the minimum viable product, version 1.0. And we will, of course, we won't stop there. As soon as we launch the minimum viable product, we will continue working on the next generation and then the generation after that.
Tom, you were going to ask a question before I jumped in, sorry.
Well, I was just going to ask, it seems to me that one of the things that, there's probably some licensing things you have to deal with, regulations that, buy-in by regulators that the technology is safe, right?
Right. So there are no clearly defined certification requirements as we speak. So especially in the United States, both the federal and statewide regulators are adopting a kind of close hands approach, but not completely hands-on and not completely Wild West. There are some guidelines, there are some expectations around the safety and reliability of the systems, but this is such a newly minted and still in progress field. No established safety standards are part of the regulatory requirements yet. That's an evolving field with inputs from technology developers like ourselves, of course, the government, the regulatory bodies, and the agencies like IEEE, SAE, UL, traditional ISO, traditional organizations working on several standards.
Okay.
One of the things that really impresses me about this is the number of disciplines that are required to make something like this happen. I mean, it seems like electrical, mechanical, probably legal is probably bigger than any of those, but why don't you talk to that?
Of course, I mean, one thing that attracted both of us to robotics in the first place is that it is such an interesting cross-functional discipline that you can't get away with being a one-trick pony. You can't just be, say, like a particular algorithm expert, or just interested in computer vision, or just interested in motion planning, or just interested in designing the hardware. For any robot to be successful, everything has to fall in place. Everything has to be in concept. Everything has to be thought from day zero as a system. And that is such a refreshing way of thinking about problems and problem solving. What is the problem? How do I quantify the problem? How can I design a system to solve this problem? What are the attributes of the system? What are the components? What is the hardware? What is the software? What is this? What is that? So we've been very lucky to have the opportunity to start working on robotic systems early in our careers as graduate students. And that taught us that very valuable lesson of no matter what you are interested in or what you really would like to innovate on, you have to think in terms of a system, and you need to make sure that you have all the other components in place at the sufficient level. And then once you close that loop, then you can go on and make individual improvements in different components. But yeah, that's the beauty of robotics, is that it's not just unidimensional. It is a combination of many sub-disciplines.
I would imagine one of the toughest things in your field is the human factor, right? You've got real truck drivers with real experience and ways of doing things, and now you're adding this. How does that play in?
Yeah, we have a very experienced team specialized with PhDs on human factors for human autonomy collaboration. Both Tekin and I, and as well as a significant part of our founding team from our CMU days, we've actually spent very long time thinking about how autonomous machines and people would coexist. How they will interact, because unless we really isolate and let the robots operate in a vacuum, be it an autonomous vehicle or your robotic vacuum cleaner or a piece of robot to help on the assembly line, etc., they have to be around people and they have to do something with people. Sometimes it is in the form of just avoiding people or communicating intent to the people so that they can basically not step on each other's toes. Sometimes it's in the form of collaboration so that they need to share a mental model. Somehow the computers and all the number crunching has to turn into a concise, distilled information pieces so that humans can understand and reciprocate. Sometimes it is in the form of machines or autonomous machines guiding and guarding the people so that even if people would like to do something off nominal, the machines will be the babysitter and then will come in and save you. Sometimes it's the other way around. So there are certain things that are still extremely natural for us humans and are notoriously difficult for machines. So sometimes the role is flipped, and our human-guided convoy approach is a very nice combination of all of these elements. We are relying on the semantic understanding, if you will, reading the room capabilities of expert human drivers to prevent autonomy from getting confused and getting challenged by the variety of situations in the real world. At the same time, we are getting our autonomy algorithms to assist the human driver becoming a better human driver with the superhuman reaction times and the never distracted, always looking at everywhere nature of the machines and anything in between. It is a fascinating problem to think how machines and people will coexist.
You know, one of the things I was thinking of, in addition to the truck drivers, you've got all the other drivers, like people with cars. And how will you, so you're sort of treating these two trucks that are in, a convoy with each other as one vehicle. How do you communicate that to the other vehicles so they don't, for instance, try to get between the trucks? Yeah,
right. That communication has to be so effective, so concise that it's not disturbing or it's not distracting, because that's the last thing you want to do. You don't want to just like distract someone who needs to be paying attention to the road and saying that, hey, like, I'm about to do something, maybe you are interested in that. So that communication has to be so subtle, yet so emphasized so that it's not overlooked by the people. But that's again a fascinating problem.
Yeah, it is.
And I would imagine doing this all within the framework of what is kind of nebulous still as far as regulatory environment too, right? That has to play into it.
Yes, we see it as an opportunity rather than a challenge, actually, because the regulatory environment is, again, like, it's not complete Wild West. There is a regulatory environment, but it is conducive, it's constructive, and it's supportive rather than being prohibitive, preemptively prohibitive. And it's going to be several iterations. It's going to be a co-evolving field as we understand more about what it means to be safe, what it means to be reliable, what it means to be acceptable by the rest of the society. The regulations will form around that and formalize that.
How close are the trucks to each other, generally?
We define the following gap in terms of time instead of distance. And in the commercial version, we anticipate these systems will operate at around half a second or maybe a little bit less than that gap. That will translate to something like 10 to 15 meters, depending on your speed. At highway speeds, it's going to be close to 15 meters. At lower speeds, it's going to be tighter. But it's not just going to be the speed that will determine the ideal following distance. It's going to be a bunch of other factors like the road topology. Are you going uphill, downhill?
Mm-hmm.
The relative differences between the two trucks. Is one heavier than the other? Is the leader heavier? Is the follower heavier? What is their relative braking capabilities, etc.? So a number of factors will continuously be fed into a magical function that will spit out what is the ideal gap distance for that particular period of time.
Mm-hmm.
The other thing too is, unlike some platooning ideas initially, where you might have a whole train or whatever, right, yours are from the same company. They're not. It's not a dynamic platoon in the sense that they'll expand or grow. You're starting with 2 trucks, right? Is that?
Mm-hmm.
Yeah, that's the first bar to clear. If you cannot get that to work, you can never get to a more dynamic, ad hoc. I'm gonna meet you down the road, and we're gonna just like go convoy somewhere.
Right.
If we cannot make it work with this extremely regimented, prescriptive, well-maintained, well-defined, near identical, it will never be identical, but whatever we can do to get them as close to each other as possible. And then over time, of course, as the technology matures and as we make more progress, collect more evidence, we can then see if and when we can start relaxing some of those constraints. But here's the thing. For the optimal deployment of autonomous vehicles in general, they will almost have to be operated in a tightly strict regimen. You will have to be very prescriptive. You will have to pre-route, pre-schedule, and otherwise you cannot keep these assets operating around the clock. We are hoping that we are aiming for operating the trucks around up to 22 hours a day, and each truck to make about 1,000 miles a day.
Wow.
If we can hit that, then because these are going to be expensive assets, so you need to provide maximum uptime so that the return on investment is maximum for the customers. So everybody wants to deploy this more widely.
So how much customization of these trucks is required to be able to do this? You know, how big an investment it is, or how extensive are the changes?
Yeah, it's still fairly expensive, but the value proposition in exchange of that is so enormous that you can justify tens of thousands of dollars of hardware on the trucks, plus significant amount of subscription and service fees. We are effectively adding the eyes, the brains, and the arms and legs of a robot. When you start with a base truck, a compatible truck, we are adding sensors, different kinds of sensors, lidars, radars, cameras. There is a different kind of computing units for the high-level autonomy algorithms, as well as tighter, low-level control systems. And lastly, there are electronically controllable steering, brake, and powertrain integration elements. So that's the arms and legs part of it. So just by sending a few messages or a few bits here and there, you can turn the steering wheel, you can command the brakes, and you can command the throttle. That is basically the add-on hardware layer that transforms an otherwise traditional truck to a self-driving truck.
And to be clear, I do want to ask a question about the technology, but in your scenario, you still have drivers in each truck, correct?
The first phase that we are launching is a 2-truck, 2-driver convoy scenario, yes. So that, and its autonomy is limited to interstate segments. So when the trucks are just like leaving the depot, there's usually a handful of miles. It's not a long run, but it's a handful of miles on the surface streets until they hit the interstate. So that part is going to be handled manually, just like it is done today, so that we don't have to delay the launch of the technology until we solve complicated autonomous urban driving problem. And when they are on the interstate segment and the technology is turned on, the first truck, the driver remains in control, it remains on the clock, but the second truck turns into the self-driving autonomous follower mode, so that the driver in the second truck can then sign off, get off the clock, go into the back and rest there, take their mandated federal rest. And every now and then, at predetermined intervals, the trucks can swap places so that each driver spends enough time driving the convoy and enough time taking a rest. And when they are at the end of that highway stretch, they can turn off the system, go manual, drive off the highway, and do again the couple of miles in the final stretch of the journey. That's how it's going to work initially.
You know, one of the things it seems to me is, and again, it's your vehicle, but it's also the interaction with the traffic. Is, you know, you're supposed to stay a certain distance away from the vehicle in front of you, right? You know, depending upon how fast you're going, how fast you could brake. When you've got a two-vehicle system like this, it's going to expand that distance somewhat. You know, roughly how much more does that add to the distance you would ideally be able to keep between your vehicles and other vehicles?
Right. Since these trucks are not physically tethered, but they are electronically tethered, they almost act in unison. So you actually do not need extra stopping distance, or you don't need extra room for that. That's the beauty. For physically linked, really like long combination vehicles, that's what they call them. Then you are dealing with a different level of inertia, different level of acceleration, deceleration profiles, etc. In our case, they are pretty much like your run-of-the-mill single trucks. They just happen to be coordinating among themselves so that they can accelerate at the same time, brake at the same time, and one follows the other through the curvatures, through the construction zones, through wherever they need to go over the interstate.
Interesting. Okay.
And I think we talked about that before, but there you have some level of redundancy. And my concern was on that virtual path, that virtual leash between these trucks, the RF frequencies that there aren't going to be interference issues or jamming issues or things like that.
Or hacking.
Exactly.
Yeah, different parts of the system has different levels of safety criticality, and hence different levels of reliability numbers that we need to prove around mean time between failures, and we need to make sure that since the follower vehicle, when it's in the autonomy mode, there is no driver to take over. The driver is sleeping in the back. You cannot rely on that. So that system has to be proven to be fail operational. And sometimes for certain parts of the system, the easier or more practical way of reaching those reliability numbers is through redundancy. So you can take two otherwise less reliable systems, put them in a redundant configuration, and the collection of that system all of a sudden has the required reliability numbers. Sometimes for different parts of the system, you can achieve the same reliability numbers without redundancy, because ultimately there is some form of proof that underlying component is super reliable. There's no way that it's going to fail. So for the electromechanical parts like steering, brake, and as well as some electronic parts like vehicle-to-vehicle communication, redundancy, in some form, redundancy is prudent and is a more practical way of achieving the required reliability levels. So yes, we do have redundancy. And for some other parts, again, we look at the numbers, and the numbers tell us whether we need to invest in dual, triple, or whatever redundancy there, or the baseline reliability numbers are just enough for that purpose.
So is the communication between the vehicles encrypted?
Yeah, of course it will be.
Yeah. Okay, so you got some security elements there too.
Right.
And it sounds like you're using V2V type, the 5.9 gigahertz type stuff.
We are experimenting with a bunch of different technologies, but yes, in general, so our first generation prototypes were using DSRC. Our third generation, we are working on CV2X, but in general, we still have not committed to a particular technology. There's still a down select process going on.
Do you see any, the FCC clawed back 30 megahertz, I think it was, or 45 megahertz, I should say, from the 75 megahertz that they had allocated for vehicle-to-vehicle communications. Is that a downside for you guys, or do you have enough to?
No, not at all, because fundamentally all we are interested in is a reliable way of sending messages between two relatively stationary transceivers. So that actually gives us a larger field to play in and maintain a little bit more agnostic eye. So we have...
Yeah, it's low bandwidth, I assume, between the two, right?
Right.
And that's ironic. There goes a van behind you. So I don't think it's one of yours, though.
UPS.
Yeah.
It's none of ours.
So coming at this from an academic perspective, is this both your first startup, or have you done this before?
We've had some startup adventures, but none of those actually turned into an actual company and turned into like a real endeavor like Locomation did. So this is not our first exposure to the startup scene or the entrepreneurship, but this is the first time we are actually really, like, Locomation is like a real company now.
And who are your investors, can you say?
Yeah, of course, there are a number of, we are mostly backed by institutional venture capitalists all over the place. We have investors from Silicon Valley, like Plug and Play Ventures, AV8 Ventures, Fusion Fund. We have investors from more Midwest, Colorado-based, like Blackhorn Ventures. We have investors from Pittsburgh, our hometown, like Draper Triangle Ventures. We have investors from Japan, investors from Europe, investors from Mexico, investors from Turkey. So it's a really diverse pool, but that is, again, the defining characteristic is institutional venture capital.
And from a customer perspective, you have some fairly large trucking companies that have committed to you, correct?
Of course, yeah. We have two publicly announced customers. One is Wilson Logistics, a really well-known leading fleet, the box trailer dry van industry or segment. And our second customer is PGT Trucking, again from our hometown of Pittsburgh, and they are again a very well-known, with very high reputation flatbed operators. Both companies are considered mid-size. They have, I believe, 1,500 each tractors right now. But one of the important characteristics of those companies are that they are very fast growers. They are very aggressively growing, and they are very fast adopters of technology so that they can compound their growth.
And it seems like there's several things where you know, even in its first iteration, it helps their business model. And you've mentioned a couple of those, but what are those kind of stepping stones to, helping them?
In short, our autonomous relay Convoy, the first product that we are launching, enables the delivery of twice as much cargo to twice as far and twice as fast, while reducing the per mile operating costs by 30%. So, and even after paying the Locomation, the cost of the hardware and the subscription fees, etc., our customers will still be looking at around quadrupling their profit margins. And with that ability, that actually will give them the chance, an opportunity of going after extended revenue venues even more aggressively and grow their bottom line even faster. So it's a 1-2 punch. They will be able to grow their revenue faster, and they will be able to make more profits for each mile they drive.
So does it start to kind of compete with maybe thin route train lines or something like that? This isn't my area, but does it start to open the market that way?
In the medium term, yes. In the near term, that is still more expensive than like a traditional intermodal or those. But it is all of a sudden it becomes extremely competitively advantaged with respect to any kind of other trucking operations. And in the future, when the technology is mature enough to be deployed in solo autonomy with no driver at all, then the cost basis starts approximating, starts becoming very competitive with rail in some ways, and starts becoming very competitive with air from a speed point of view in some ways.
So when do you think we're going to actually see this being used commercially?
I mean, for our products, it's going to be late next year.
Wow. Okay.
But of course, it is. It's going to take a really long time for this to become really ubiquitous.
Yeah.
There are close to 4 million Class 8 trucks just in the United States, 3.7 million to be exact. And if we do our jobs right and if we can grow aggressively, we will have several tens of thousands of trucks on the roads in the next 5 years. So if everything is right, we'll have, I don't know, like 1% penetration. And because it's going to take a really, really long time to change everything that is required for really mainstream application of this.
Does it become kind of like a franchise type thing where you provide the technology to certified installers or whatever?
That's the idea. We are always prioritizing staying lean, staying focused on what we know how to do best, and form partnerships with our valuable partners who knows what they do best. So for installation, service, maintenance, we have a strategic partnership with the largest truck dealership in the United States, Rush Enterprises. They will handle the installation, they will provide warranty, they will provide service and repair because that's what they know how to do best. And we are working with tier 1 suppliers and OEMs on the actual vehicle integrations because that's what they know best. And we know how to build robots best. So we are sticking to our core competence and staying lean.
Wow, it's really fascinating what you guys are doing there, and I like the taking the simple concept and just trying to perfect that. Especially because a lot of roads, in the U.S., the really long stretches are 2-lane roads. We talked about that earlier. So going more than 2 trucks would be big logistical issues, I think.
Yeah, it becomes everybody instinctively thinks that this is a bigger technical challenge, but actually the technical challenge there is not that big. The bigger challenges, as you said, are logistics challenges of lining up 3, 4, 5, 6 trucks at a time, and social challenges around, like now you are looking at a road train that is slower than the rest of the traffic, that's like very long, it's impossible to navigate around, and people are going crazy. So dealing with that. And lastly, some of the states in United States has very old infrastructure elements, like some old bridges, etc. Some of them are might not be rated for the weight and the vibration characteristics of longer convoys. There are some research groups actually working on characterizing all these infrastructure elements and determining the optimal convoy allowance, if you will, there. So on this bridge, you can operate with 3 trucks going at 40 miles an hour, but on this bridge, you can only operate with 2 going at 50 miles an hour. Things like that.
Wow.
That's Are there any limitations with the 2 right now, or is that?
No, 2 is perfect because it's literally the minimum viable product. I mean, you need at least 2 to do the convoying, and
it's not too heavy for bridges, then, huh?
Exactly.
And this gets to back to that whole multidiscipline thing, right? Of having people around to think of those kinds of obscure things I wouldn't have thought of.
And that's something I think we need to do a better job in general about helping people to be multidisciplinary, to be part of teams that span various technical disciplines, for example. And do you have difficulties finding people like that? Do you need help training from institutions train people to do that?
Of course, we are always looking to find and hire very, very talented teammates. We are very proud of the team that we were able to build so far. We were able to convince fabulous people to come and join us and join forces. But of course, we are still in our growth phase, so we will be looking to hire many more people. And you said something really, really important, Tom. We need to do a better job in training interdisciplinary or multidisciplinary people. That's not traditionally how the academia is set up, and how the research is encouraged. Because in academia, you are encouraged, or maybe even forced to become more and more specialized as you move, instead of becoming more and more of a polymath or like a Renaissance. Renaissance people are usually good. They know a lot of things and they have a lot of fun, but they are not considered super deep academics because they haven't gone that deep and that narrow in one. So there's a little bit of a metric and success metric issue that maybe worked on. And maybe some other clever things of like, how do we expose people to as many disciplines as possible within the formal framework, so that they can pick and choose. Do they want to be one? Do they want to be five? Do they want to be anything in between? Like,
right.
How do you mix and match there?
Yeah. So Ken, I probably got to get off here pretty soon to get ready for this next meeting, but this has been really, really interesting, and I'm really glad to get a chance to talk with you guys too. Thank you.
It's been great meeting you, and we'll be supporting you and applauding on the sides forward.
If you're IEEE members, be sure to vote.
Oh yeah, of course. I mean, we've been, both Tekin and I have been members for about 20 years now.
Excellent, good.
And so, Tom, I'll catch up with you in another in a few minutes. I just want to thank you guys very much for being part of this. I also want to reiterate what Tom said. Tomorrow, we're having the live event, the IEEE history event at the Computer History Museum. It'll be streamed, and I'll tweet that out. And also, the Smart Driving Car Summit, Alan Kornhauser's event, is November 2nd through the 5th. I think it's going to be live in Princeton. So I wore the shirt in honor of him. It's a great, fun event.
Yeah, say hi to Ellen. I'm a fan.
I
will.
Hey guys.
Thank you guys very much.
Thank you so much. Have a wonderful
Take care.
I really enjoyed it. See you later.
Bye. Here we go. Yep. Take care, Taken.